Hello, I'm Sourabh from University of Maryland, and I'm working under Dr. Niklas Elmqvist from our house university. In this paper, we study 3D real-time telemetry for post-game analysis in the context of combat flight simulator, and then propose a suite of tools called TACREAL for collecting, visualizing, and analyzing spatiotemporal data. Telemetry here refers to any data collection from a game, including, but not limited to, quantitative metrics such as position, orientation, and velocity, or discrete events such as shooting, reloading, or changing position. Analyzing telemetry data can support players in improving performance as well as spectators in weaving data-driven narratives of the gameplay. Flight simulators are a special case because many simulator pilots study their performance after a flight to understand their mistakes, how to address them, and how to improve them. Their activities fall into three broad categories, which are interaction with the data, making sense of it, and then validation of their decision-making process based on the previous decisions. For this study, we use Digital Combat Simulator or DCS, which is a comprehensive combat simulator for PC focused on high realism. The simulator is considered study level, which means that players need to read detailed manuals just to perform even simple procedures. One of the social aspects of this game is called virtual squadrons. Virtual squadrons are stable groups of players flying together under common goals and values. By embedding ourselves within the VF1 Wolfpack virtual squadron over a period of several weeks, we conducted an in-depth observational and interview study to understand the data collection and analysis practices of the flight simulator players. In our formative evaluation, we conducted several interviews with dedicated squadron members to better understand the domain and their visualization and analytical needs. These interviews followed a semi-structured protocol and were conducted in both groups as well as one-on-one sessions. Players felt that debriefings are what puts organized DCS players apart from other online games. Another reason for the debrief is that it is a routine occurrence in real flight squadrons and thus should be simulated also in the virtual squadron space. During the debriefs, the different air crews will take turns going through the recorded data to discuss what went right, what went wrong, and often offer constructive criticism to themselves and others. The major user experience challenge we found was that it was difficult for players to locate and communicate information about the game events in their debriefings. To address the shortcomings of existing tools for 3D telemetry analysis, we proposed TACREAL, a web-based 3D visualization tool that allows virtual pilots to explore, analyze, and share combat flight simulator telemetry data. The TACREAL player is a 3D telemetry visualization tool that enables the users to navigate freely in both time and space of the playback. The TACREAL Director tool allows users to author sequences or reels consisting of multiple clips. This enables the users to condense, summary, or highlight reels that decrease the full length of a telemetry stream consisting of hours of data and hundreds of units into smaller and more manageable sequences that can be viewed in the TACREAL player. The Director tool integrates event timeline visualization where users can either select predefined events for inclusion in the clip or define new clips by selecting directly one or more units and a time period of the timeline. These highlight reels can potentially generate interest and capture takeaways of major events during the debriefing. The design goal for the TAC reel was to keep interactions fluid and to support every step of the visualization pipeline. This also required the system to run at 60 plus FPS and with less than 500 milliseconds of response time on all interactions. We achieved this by carefully splitting the computations on the front end and the back end. The backend allows users to upload the replay in ACMI format and parses it into a JCMI uh, data frame and streams it continuously to the front end. The front end uses 3JS library and several free open source 3D assets for recreating this simulation data and is controllable through our custom built 3D player. For our summative evaluation, we use the needs, requirements, and current gaps in the practices from our formative evaluation. We then participated in two separate squadron missions as embedded observers. Participating in a mission involved listening in on the briefing, watching the stream from one or several of the participants during the mission, and then participating in the debriefing after the flight. During the debriefing, we uploaded their replay and asked them to use TAC-Reel to debrief the mission. Participants were also encouraged to use TAC-View for the same purpose, to allow for comparison of comparing and contrasting of the tools. Even with 40 plus years of combined experience with flight simulators, mission participants sometimes had confusion about communications during the game sessions. All participants agreed that having an audio overlay of communication from on top of the 3D telemetry player would be beneficial to resolve confusing and confusing conflicts for the training purposes. All participants appreciated the summary reels, especially the control they had on these events. Some mentioned that it would take them time to get used to the new workflow, since they are used to verbalizing the events during debriefing rather than visualizing them. Many participants appreciated the ease of opening a browser-based tool that was accessible to everyone immediately, instead of having a native application that some people lacked access to. In conducting this work, we opted for embedding with a single virtual squadron rather than broadly engage with the DCS or even entire flight simulator community. This means that our findings may be very much local. All participants mentioned that they had been exposed to simulator games early in their lives, and all of them played at least one other simulation game other than DCS Flight Simulator. In other words, while the VF1 players surveyed in this thesis represent a specialized segment of the entire online gaming population, we do not think that they are far too different from the rest. For this reason, while our study was focused on VF1 squadron, the challenges and the feedback from the squadron might mirror those of other virtual squadrons or other online communities that engage in the cooperative virtual missions or games. TAC-Reel is in its prototype stage and as such represents only a starting point for summarizing spatiotemporal game data. Future versions could also integrate real-time collaboration and enhanced communication features such as annotation, camera views, camera movements, transitions between events for better storytelling. Lastly, the core features, especially the 3D player, is built for any telemetry data and could be extended to other simulation environments such as ground combat simulators or even arcade simulations or action or combat arcade simulations or even action games or even sports games. Thank you.